Hello everyone. Nice to see some of you back. I think we have a few fans that are here about every time we have this town hall. It's only once every 3 months, so we do have a lot to share again. And especially at the end of the year, we'd like to reflect on what we actually achieved in a full year. So let me see if this works. Yes. So just to recap again, what ARISE stands for. Basically, we have 45,000 species in the Netherlands, and we're not able to identify each one of them, at least not to date. And this is exactly what we're trying to do. Can we have the technology to identify any species in any location using various methods, such as DNA and other technology? Altogether, this should lead to a connection of databases, of infrastructure, of services that allow us to question which species is where, under which circumstances, how is this going in time. But we start with the identification itself. And that already requires quite a number of data flows, new processes, new laboratory equipment, or AI modules. And that's what we're working towards. Also remembering, we have 5 teams within ARISE. Each one of them is focused on a particular assignment. So we have the sampling team that's going for streamlined sampling, sequencing, same way, but also making DNA barcoding and metabarcoding cheap and accessible for any researcher. We have an AI team focused on digital species recognition. The BioCloud team is fully focused on all the data management, knitting everything together. And the monitoring demo side team is testing various sensors, but also the data flows behind those sensors and how many sensors should be in place on a given location to get a real view on the biodiversity. These are the team leads. Some of them have already signed off for the year. So some of the team members will take over, which is fantastic. That also means that the teams are quite mature now to actually talk about what they have been building so far. We're building end-to-end. So this is the general picture of ARISE. But what it means is that we made a few choices already last year and which we continue to work on this year. So for instance, one of the big use cases that we wanted to achieve end-to-end is, can we have a streamlined process from collection to DNA IDing, storing the data, exposing, and then allowing end users to explore the data. Now, obviously, this is a massive task. So we're not there yet, but we have made pieces of the puzzle that we're now trying to knit together. The same goes for the more digital way of identifying species, focusing on the insect camera. But of course, this is just an example of any type of sensor that can be deployed in the field. Can we harness that data, put AI modules on top so we have easy identification, expose that data, and then knit it together with other types of data for exploration? This is in a nutshell how I feel we had 2022. Lots of things happening, teams in the field, presentations to get to know the community better, but also identifying new species in the Netherlands or exploring how we can facilitate users in an online environment. We have a new radar. Everything will actually be discussed by the team lead. So without too much further ado, I'm going to hand over.
So I hope everyone can hear me. Yet again, my name is Hanko. I'm the team lead for sampling. And I'd like to take you towards a little recap of what we did last year. On the next slide. Yes, so these are the goals we set earlier this year for team sampling. We wanted to go from 5K samples to 100K samples per year. We like to build a reference database and work on end-to-end samplings and storage strategies. And further on, also trying to reduce time in the whole workflow and still get this high throughput. So let's take a look at how we did. We started with the reference database. In October last year, we had a database set of 19,000 barcodes of close to 6,000 species. But now, thanks to Kevin, his team and analysts, we are at a data set of 1.5 million barcodes of 25,000 species. So that is a great step forward and gives us a lot of insights to work on. And we can see maybe on the right corner that for animals, for example, we are at almost 68% So we also processed a lot of specimens. In the next slide, we can take a little look at some of the results from field experts. And this shows that already over 15, now close to 1,500 species we've received from field experts just on the go. And these resulted in quite some new barcodes. I've separated them in certain shares, but it's in Dutch. Sorry for this. I might have translated it for you. But this results in the next slide that we are now not at 68%, but at 70%. So we got a few percent extra now. This is just a tip of the iceberg, because on the next slide, we can see that we are also worked a lot on the AWD pilot. Week 1 and 2 are more or less completed in processing for subsampling. And the third week, the last week that we did in September, is in progress. And this will result in roughly 15,000 specimens. So this will add up a lot of new species as well. And we had 2 students working on a voedselbos from Brabant, and this results in roughly 600 to 800 species. So this will add another decent number of probably new species. And this tested also our workflow, and it's surprisingly student robust, I must say. We did a lot of workflow changes throughout the year, and this is easily displayed in this graph that we really work towards getting more production on our site. And this shows that we can already prove that we can go from 0 specimens almost in December, January to 20K this year. You see a dip on November, December. Well, November, we had some other things also to do, but in December, we are only halfway. Well, it's the 13th only, but we are already closing the 25 plates for this month. So probably double up maybe towards the end of the year. So that brings us to over a process of 20,000 specimens. And this is without meta barcoding and we are not even at full capacity. So I think this is already a good start for us. Yeah, when it comes to reducing time, we're also working on the sampling tool. This will cover a lot of our data work, and it's currently in the building phase. And we first start testing scheduled at the 19th of December at the end of this week. Small tests every 2 weeks. We'll get a few things to test, and hopefully by January we got something to show. So that's maybe something promising to look forward to next. There was a little drawback there though. They had 4 students on this project, but they lost 2 on the way. Don't ask me how. That's something probably due to sickness or anything, so nothing urgent. But okay, let's go to the next slide. This is an example of one of the workflows we have for all the steps that we have to go through for specimens we receive from field experts. And if we take a look to the next slide, you see coloring. All the colors is which steps the sampling tool will probably help or affect or even completely take over. For example, data control and data import might eventually be completely taken over by the sampling tool. So it does affect a lot of our complete workflow. And then we got a little video from Westerdijk. Margarita prepared this for us, and it shows a little bit about the workflow. You may start it. At Westerdijk, they have been processing near 600 soil samples in order to get pure cultures out of them, of fungi, and preserve them, these for the collection. In this process, they have created about 8,700 fungal cultures. And these cultures are currently in the process of for getting DNA extractions and sequencing. Kevin will likely tell more about this. And they are working on identification of these cultures. It still needs to be done for most of them. And it holds probably a lot of new species actually for the Netherlands. And those are yet to be described. And this video shows a little bit of the diversity they come across. So I think this is very interesting because we hardly ever see in images like this ones. But these are all the fungi they find throughout the process and isolate and try to get the DNA from. So it's almost finished. Great. Yeah, so I hope this gives a little impression for Westerdijk. Thank you, guys. Other things that happened in 2022. Maybe you remember that I told about collection mining and we had to put it on hold. We will start it next year, more about that later. And from the 5 to 100K specimens in June, we had the goal of hopefully getting 10K specimens by the end of the year. but it was already achieved in November, early November. And by the end of the year, we had 20K specimens. So that's even double from what we expected earlier. And eventually in 2025, we'll hope to have reached 100K, of course, and tested the whole pipeline throughout to roughly. And we had a strategy meeting for our targets of next year. And mainly we have a good production, so let's focus on our missing species, was one of the results. And some of the goals are like policy-related species, filling at least those gaps, pollinators, because those are quite really important in various projects, and also in BGE. BGE is the Biodiversity Genomics of Europe, and one of their goals is also pollinators, so maybe we can have a little bit of cooperation there. We start collection mining again because we start having the first results, so we can start discussing with collection managers of how to approach collections and set new targets or inventorize of the possibilities there. So we're going to first inventorize, and this is also important for BGE. We will focus on expert networks, start testing the sampling tool, and of course, meta barcoding will become a bigger focus now. Dion, a student of us, is working on that next year more in depth. And also biobanking will become more important because we have to find out how to deal with all the results and the tissue collection and molecular collection and work this out. Next slide. Yeah, Kevin is. Even.
Yes, can you hear me? Shoot. So, hi, I'm Kevin, team lead of the sequencing team. Go to the next slide. Yes. So just a recap on our main goals. As already mentioned before, setting up the whole pipelines for the DNA work, for barcoding and meta barcoding, making it more efficient, quicker, cheaper, more high throughput. So we need a bunch of, okay. That was a really quick recap. So we started the year with this sort of graph, which looks like a really complex layout of all the things we're doing in the lab. But if Elaine clicks on the next slide, we can see what we've achieved this year. So in green is all the stuff that's done or completed. In orange, we marked things that are still in progress. A bunch of things are in progress in student projects at the moment. But we still have some things to do, which I will get back on in a few slides later. So next slide. So update on the nanopore barcoding. So we finally started our production phase. So we're working in batches of 24 plates. So all the backlog that we have built up over the last couple of months, because Hanko's team is working a lot quicker than we anticipated. We now hope to process quickly. So on this picture, you see a whole stack of plates. That's basically what goes in. And in the end, we have this one tube with this tiny little droplet of what looks like water, but actually has a lot of DNA in it that we sequence. So we now have a grid ion up and running. We get about 3,000 reads per sample. So we can do a lot of interesting things now. As the next slide will show. So we're working on, of course, also the bioinformatics on the other side of the machine. Basically split our pipeline into 4 different parts, where now we focus on the second part, which is the generation of consensus sequences. So the actual barcodes. So we get a lot of reads and we need to combine to get the barcodes themselves. We're tweaking the pipeline a bit, and we now get actually a lot better results. We see that the data quality is improved with the new kits, but also that we get more sequences from samples because we have so many reads, we can actually see more of the background. And in some samples, previously, we only got the bacterial sequence because that's the sort of a contaminant or a parasite within the insect. That was the majority of the reads, but now that we have so many reads, we can actually find the actual species in the background as well. So that's great. So in the next slide, as Hanko said, we also at the Westerdijk be sequencing a lot of cultures. both cultures from their own collection, so where they focus on isolates from soil samples that already exist within the Westerdijk collection. So there's about 4,500 isolates which have been sequenced, more than 2,000 of them from Dutch soil. And then also, of course, the samples that have been freshly collected, which are summarized on the next slide, where there were just under 600 soil samples, but almost 9,000 cultures were obtained from those soil samples. And so that's a really nice set of new material coming in, and a lot of it still has to be sequenced. But I mean, it's an ongoing process, especially with so many cultures that need to be sequenced. So I think the next slide sort of summarizes the status of the fungal barcodes. So there's also a need to edit some of the unpublished barcodes. There needs to be some data validation as well. So next year, the plan is to finish editing over 6,000 sequences. So that will vastly improve the reference data, and then also generate data for more isolates. As you can see in the picture at the bottom, about 90% of the DNA extractions are done, but from that 90%, about two-thirds are PCR'd, and from that, only about 70% is sequenced. So there's still a lot of samples waiting in the various steps of the process. And this sequencing also, yes, that's okay. So one of the highlights for this year was that there was 3 new fungi, including 1 new genus, and that are currently being described. And here you can see some of the pictures of what it was, what it looks like when you look at it under a microscope, and not these fuzzy plates that look like moldy bread. This is actually how pretty they look. Okay. Also, the target list, well, Hanko already mentioned it. Target list is getting a little upgrade. So in our new and improved website, it will have a bit of a visual makeover. So this is a little preview for those of you who are here. This is what it's going to look like, but it's not online yet. So a little patience. So one of the components we are really starting to work on is the sequence database. So we want to have all our sequences in one easily queryable environment. So we did a hackathon together with the eScience Center and a bunch of people from within Naturalis as well. Basically, we came up with a simplified data model, and a whole bunch of data was already ingested. We explored some alternatives to query the data. But in the end, the idea is we want to have sequence data readily available, so that when we say, give me a reference data file for all the plants from the Netherlands, it's just 2 clicks of a button and you get your sequence data to do whatever blast you want. So the outlook for Q1 of next year, we just had a visit of the people that are going to install the new DNA extraction robot, which will come in January, and we have to probably take the wheels off to be able to fit it into the elevator, but we'll fight with that next year. We're also hoping to have some more insights on the LIMS, so the laboratory information management system, to be able to track all the data for the samples that go through the lab. And then for the bioinformatics, now that we have the consensus generation more or less complete, we want to really work on data validation. So we get a sequence, but is it actually a correct sequence and not, for example, a Homo sapiens contamination or missing base pairs? So we need to work on some data validation pipelines as well. And in the background, of course, there's a bunch of students working on various things to develop and optimize various protocols, including DNA extractions for museum specimens, which I hopefully will have some more pictures on at a later stage. And then finally, as sort of a further outlook for the rest of 2023 on the next slide, We are still assessing some of the bottlenecks, especially where it concerns data storage. But we also want to have the pipeline that we now use for our nanopore sequencing up and running in an environment where everyone can use it, so that we're not reliant on bioinformaticians to work in the command line, but actually have something where raw data can go in and clean sequence data can come out, so that students or other researchers or people can do it themselves. And we're going to work on some more skimming, but more on that later, and going to revise some of the protocols once that robot is in place. And that's it for me.
Okay, so my name is Julian Evans. I'm a data scientist for the monitoring demonstration sites, and I'll be giving the presentation today. So the idea of the monitoring demonstration sites is to demonstrate and test a wide range of sensors in diverse environments and showcase them to the scientific community and the public. And in 2022, we mainly focused on 3 demonstration sites, so an urban site in Amsterdam, and dune and grassland habitats. And at each of these sites, we deployed a wide variety of sensors in which we accumulated a lot of data from various types of sensors, so different cameras, acoustic recorders, radar, and insect monitoring devices. And this is a lot of data for us to handle. Can we have the next slide, please? So one of the main jobs we had this year was to construct a pipeline to organize all these different types of data coming from all these different devices and sort of consolidate them and put them somewhere safe. So we've now established this automatic data pipeline that collects data from various devices, organizes them, and puts them into long-term storage in the SURF data archive. And our devices broadly fall into 3 main categories. So we have devices that transmit automatically to external storage, which we then need to gather in, and so we collect that using our server. We have devices where data still needs to be manually collected and downloaded. And then finally, we also have these more smart programmable devices that can actually just send data straight to the server using an API call. So can we have the next slide, please? So in the case of manually downloaded data, we have also developed, as part of this pipeline, software that allows for bulk downloads from various local storage, such as SD cards and external hard drives, and can then upload them to our server. And can we have the next slide? And for these devices that can automatically transmit, we've developed a portal that allows us and our stakeholders to easily monitor devices out in the field, even using their mobile. So this has been one of the big things that we have done this year. And so moving on to next year, can we have the next slide, please? So what we want to do is hook in a few more of these data of these sensor types into our pipeline. So we mentioned the radar, but we're also looking at other types of audio loggers and new types of cameras. And we also want to obviously then explore how we connect the SURF data archive, all that data that's stored there, to the BioCloud at some point. And we also will hope to discuss how some of the features I just showed might fit into a wider ARISE strategy. So can we have the next slide, please? But now we've got the pipeline up and running. We, as shown in the last town hall, we're going to implement a large-scale wildlife camera sensor network at AVD. And we're also planning to consolidate the sampling design at other sites. And we're also planning to pilot new sensor types, such as the bug acoustic recorder and smart nest box cameras, which are developed by the University of Twente. And as we're also looking into bringing in GPS tags into the system. And we also still want to explore aquatic sites and sensors at some point. Can we have the next slide, please? And finally, we also want to develop and trial several new types of sensor prototypes, for example, smart programmable wildlife cameras for better autonomous deployment in the field, and modify existing sensors so that they can last longer in the field without us having to go and collect data constantly. But these are our main goals for 2023. But yeah, that's all from me. Thanks.
Sorry, we had to unmute here over. So my name is Freek and I'm a member of the Digital Species Identification team. And I will give the presentation today. The goal of our team is to sorry, we have an issue with the slides now. Yes, there's where we should be. So the goal of our team is to identify any species in any type of medium, which is a very big challenge. We are currently working on images and sound, but we'll look at other media types later on. Here you can see a sound sample where the same bird as before has been recognized. And here are some more examples of wild mammals. On the left side, the two pictures show pictures made by drones. And on the right side, the Diopsis insect camera and some underwater photography. So we try to recognize species everywhere. And to be able to do that, we need a lot of AI algorithms. So that's the reason we are building a repository for those algorithms. And the goal is to make it really easy to do your analysis, whether you have images from the Diopsis insect camera, or whether you have sound, or maybe video, or GPS, or radar. It should all be easy to analyze, to do your analysis. So what have we been doing in the past 3 months? One of the biggest highlights is that we have had some contributions from outside of our team. And we also improved the support for the community for that. Several student groups have been working on adding AI algorithms to the repository. And that allowed us to test our templates and documentation for that, to make it easy to do that. The student groups worked on human detection, because in what we want is to either exclude images with humans, or maybe be able to blur them out, so we don't have any privacy issues. And here you can see some of the algorithms and the results that they get. The top row is the original, the 3 original pictures. And then the second row, you see the human parts being colored. And in the third row, there are bounding boxes around the human parts. So the algorithms are quite successful in detecting human parts, even with small parts being visible. So to summarize, we've had our first community contribution. We were able to improve the templates and the documentation for external contributions. And we now have an open source repository to store algorithms in. Another topic that we have been working on is connecting the Dutch supercomputer Snellius. We've been scaling up data sets. It's still at a very modest scale with 4,000 images, because we are planning to process in the tens of millions of images. But yeah, we have to start small to make sure everything works. And the processing was successful, but we noticed that there are quite some areas where we can optimize it to speed up the process. So we're working on that. Also, a lot of updates on the user interface. which is progressing very well. As a few highlights, here's the start analysis screen, where you select an algorithm in a data set and can start your analysis. The dashboard has been totally revamped, showing recent analysis jobs and recent data sets now. And here it shows the media browser screen with infinite scroll, which is going to make it a lot easier to prepare data sets. Also, in close collaboration with Team BioCloud, and Chantal will tell a lot more about that, I think. We've been working hard to prepare the DSI software for the new BioCloud. And we are absolutely looking forward to switching to that new system. So our outlook for next year, we want to do large-scale data analysis on the diopsis images, while also adding support for wildlife camera data to enable the diopsis data analysis. We want to migrate to the new BioCloud system and improve support for Snellius. And finally, we want to refine the AI model repository and work on AI evaluation and comparison, and also start working on interactive data annotation module.
All right, then I think it's my turn. Chantal Huibers, I'm the team lead for the BioCloud team based at Naturalis. The BioCloud team has a pretty large task. Elaine, do you want to click to the next slide? As we are building the entire underlying infrastructure for Arise, kind of accommodating all the data and services that the other teams are building. And you can see from the updates from my colleagues that they're working very hard and they're all knocking on BioCloud's door with data that they want to have stored and indexed in the BioCloud, but we need to start somewhere as well. This is kind of the image that you might have seen before of what we want to achieve eventually with a central platform from where you can access different end user services, whether you just want to look up some data or connect your own device, explore algorithms or analyze your data with an algorithm, or even build an algorithm yourself. They are a suite of end user services that we have in mind to provide to the Arise users. On the left side, you see the suite of other infrastructures, and this is just an example of some of them that we eventually want to connect to. But as I have mentioned in earlier presentations, what we first really need to do is build the foundation for all of this, which starts with backend facilities to properly store and manage all this data, provide proper access control, and some API service. So the focus for 2022 for our team has really been on the bits in green. It's been quite a journey, I have to say. You already heard Freek talking about migrating to the new BioCloud. Elaine, if you want to go to the next slide. So at the start of 2022, we started with a prototype for BioCloud built on a Postgres solution, which seemed to be working for our diopsis use case, but we also felt there were some needs for making it more scalable. So we did a bit of architecture and design kind of phase. And we decided to really start building towards a data lakehouse architecture. So this kind of combines the traditional data warehousing with the more unstructured data lake concept that came after that. We don't want it to be a swamp. So we do build a data lakehouse, and one of the main components for that, for indexing and storing metadata, is Delta Lake, which is an open source storage framework, and a few of the things that are key for using that is that it allows schema evolution. So we kind of have some kind of structure to the data, but it can still grow and evolve as Arise grows as well. And it also allows for time travel so that we can look at the data at any point back in time, which is very important for provenance of, for example, training data sets when we look at training algorithms. Next slide, please. So once we kind of decided to move to this Delta Lake system, we've been working very hard on the data management system, still for the Diopsis insect camera use case. And what this kind of means, iRods is a storage management software package that can manage where the actual payload, so the images in this case, are stored. And we use Delta Lake for managing all the metadata. We now have a system where we can ingest raw metadata in any format, so whether it's a JSON or an Excel file or a Postgres file, and we have a generic translation methodology to go from raw to enrich, so that makes it a bit more structured in a format that we can query. However, we also were working very close in collaboration with the DSI team, and they wanted some fast read and write access to that as well. And Delta at the moment is built as a batch framework. So we are synchronizing to Postgres for a curated fast read write access database. Next slide, please. And together with the DSI team, they've been kind of working from the other end backwards to have an API to connect to that whole data management system, from which we can query the data, access the files, and send them either to the computational side for analysis or to the UI for viewing by the user. So Elaine started the story with saying that we really have adopted this end-to-end approach for Arise. So rather than working just on a data management system, we really want to make sure that we can serve a use case to our users end-to-end. The green arrows show that we're almost there from our end-to-end perspective for Diopsis. So we already had images going from the camera to the server, but we can now ingest them straight into BioCloud, serve them to the API. We're still tying together the loose ends between the API and the DSI bit. So this is where the DSI team and BioCloud are working together to move the DSI parts onto the new BioCloud, as we now call this. And then the Arise platform, as you just saw, is already pretty much in a phase where we have a first prototype that we can start using with some end users that can test, so they can actually expose and explore their images. So from a Diopsis point of view, I would say it's looking quite well for a first MVP. Now, one of our priorities or our aims for 2022 was to use the same kind of data management system for another data type, in this case, the sequencing data type. We didn't get as far probably as we would have liked, but we did have, as Kevin already said, a hackathon together with the eScience Center, which was a great week where we had like 12 developers in a room together to actually test whether we could use this Delta prototype for the sequence data as well. We got quite a bit, so we actually did ingest data and were able to translate them from raw to enriched. But at that time, we didn't have some parts of the rest of the pipeline ready yet. We will move forward with this in 2023 and hopefully then also make the sequencing data available through the API and in the platform. And then, why are we doing this? The idea is eventually that we can store any type of data. We'll still make a decision with the team leads on the next data type as a priority once we have the images and the sequencing data in. But it should become easier and easier to add data types once we have this generic methodology of storing and managing data. So it's quite exciting to actually finally see a system almost ready to be tested, with like scaling up more images, going from those 4,000 to 1 million and so forth. One of the other things that the BioCloud team kind of has on their plate is the Arise platform, so the UI. Well, we kind of didn't really have enough resources to do that all within the team. So we contracted Flores.nl. They also are responsible for developing the sampling tool that Hanko showed. And they have started to work on the first MVP of what will be the Arise platform. This will have kind of a homepage where we welcome you to Arise, the improved interface of the target list that Kevin already showed you, as well as a link to the interface of the digital species identification work that Freek showed for viewing and the images of the diopsis and the results. And then finally, our outlook for 2023, we're going to have a busy year, as all the other teams will as well. We are working towards getting the MVP for diopsis images ready for testing with end users, hopefully within a month or so, well, end of January, something like that. Simultaneously, we'll work on moving forward with managing all the sequence data. We're still also working on user management and persistent identifier generation to have that all automatic as well. And then we really need to start thinking about how do we move from these prototypes, MVPs, to really move this to production for the mass users, I would say. That will be that will be very exciting as well. When we can actually share this with more than just a few end users. Front end the same, we'll get ready for some user testing. And there's already bits and pieces of UI built by the other teams as well that we will prioritize for adding to the Arise platform. And then there's a whole bunch of other things that is on the next to-do list. We'll have a session with all the team leads to kind of prioritize, is it going to be sound data or linking to all the data that Julian showed that's in the SURF archives, moving towards species reference database. We know that BioCloud team cannot do everything at once, but we'll definitely try to work towards as many of the use cases as possible. That was it from my side.
Right. Thanks, everyone. So in just under 45 minutes, I hope you're overwhelmed with lots of technical stories. I hope you didn't get lost. Arise is complex, and that's just because biodiversity is quite complex, and especially if you are trying to identify every species that there's around. Obviously, we're building this for the Netherlands, but that doesn't mean the technology cannot be scaled outside the Netherlands. And I think that's something very important to understand. We're not here to replace any of the activities that are already happening, but really to find the pieces of the puzzle where we can add value and where we can connect to other initiatives. So a lot of things are happening in Arise, a lot of things are not happening in Arise, but it's important that we all work together with these large initiatives to really get this off the floor. So big thanks to the team. They've worked incredibly hard. I think, including myself, there's a lot of small viruses going on because we're a bit done with the year, just showing how much we have given to this great effort. So well-deserved holiday break for each and one of you. But also a big thank you for those listeners that are joining us every time to find out what's happening, maybe give us some feedback. So kudos to you as well. And hopefully we can even interact a bit closer with you in the upcoming year when we have real prototypes that can be tested. So please don't run away. Please stick around and give us some feedback. I am going to stop the recording though.